Well, here we go with Theorem 511, that is the indirect proof of it, and that's simply we're going to prove red angle is bigger than blue, so the red side's bigger than the blue side. So let's consider the three possibilities. This is how an indirect proof works. We're going to look at, there's only three possible outcomes here, and we need to reject two of them. Well, either the red side is bigger than the blue side is bigger than the red side, or they're equal. Well, let's just get right to it then. Let's make this assumption. I'm going to say this is smaller than this. That's my assumption. Now, okay, this is actually pretty trivial because I'm going to use Theorem 510, which does make it pretty easy, because Theorem 510 says very, very quickly, all right, well, if one side of a triangle is longer than the other, then the angle opposite is larger than the other. So that by making this assumption that the blue side is bigger, I am now concluding that angle E, the blue angle, is bigger than the angle D. But that's a contradiction, because you see, so I must reject this possibility right here. So I can reject that. See, because that contradicts one of my given statements. My given statement, we just proved that the measure of angle D is greater than the measure of angle E, and in fact that goes against my given. It is a little hokey because, after all, we're using Theorem 510. Let's try this one. Let's make them equal. A little more interesting. Case number 2. Well, if they're equal, we can go back to our base angles theorem. Our base angles theorem says, well, I've got two sides of a triangle equal. That means that their bases are equal, or base angles are equal. So angle D is congruent to angle E. And that is just plain false. It's false because it contradicts my given statement. So I can cross that one off. And you see, by eliminating two of the three possibilities, the only possibility remaining is this one, that EF is greater than DF. And that's your proof by contradiction. Now let's do one of these indirect proofs in our classic two-column form and see. This one's a little bit easier. You got a hint for it down here, and we want to prove that this red segment is the shortest distance between a line and a point not on the line. So let's get right to it. Get rid of that plan for proof. We know that. This time, we really only have two conditions, or two possible outcomes. Either this is the shortest distance, or it's not. So we're just going to disprove one of these cases and see. There we go. I'm going to start with this assumption. Where'd that come from? Well, I made it up. That's all you have to do. I'm going to say, okay, there's a segment AC, which is shorter than the red segment. So the orange is shorter than the red segment, because I say so. I like that. Now, I say, okay, well, if that's true, let's just consider a couple consequences. This angle 2, which is opposite the shorter side, is smaller. Or another way of saying it, angle 1 must be larger than angle 2, because after all, I'm making the assumption that that red segment is the longer of the two sides. I know it doesn't look it, but you have to go with the words. So now, if that's true, angle 1 is greater than angle 2. And angle 2 is 90. Perpendicular lines form right angles. Okay, you see where this is headed. Now I'm going to say, all right, these two angles add up to more than 180 degrees. Since 1 is bigger than 2 and 2 is 90, I've got a triangle here. You see a problem. You should see a problem right there, because that produces a contradiction. This contradicts the triangle sum theorem, because I now have this blue triangle, ABC, which exceeds 180 degrees of interior angle measurement, and that's only using two angles. So that just cannot be. And that means I must reject this assumption, and I'll say this assumption right here, and that's just plain wrong. And the only thing that's left, since there's two cases, it's either I assumed it wasn't the shortest segment, now I can say The only case remaining, AB is the shortest segment. So there's your proof, indirect.